I love this cartoon. If you guys think that I'm anti-cell phone in the classroom, you should see me on the road. So today we get to continue on with fundamental counting principle. We're taking this one in pretty small chunks. Today's going to be a very short lesson, just a couple examples to do, but we are getting into some tougher stuff. So I'll get you to turn to page 65 in your workbook and take notes along with me, please. So we're on page 65 and we're looking at example 3. And what we're getting into today is working still with restrictions. So we had a few restrictions yesterday. We're still looking at how many ways can you complete a task, but having certain restrictions. Now, one of the things we did talk about yesterday, I want you to circle or highlight, is that we always deal with the restrictions first. Okay, and you'll see this today as we go through our examples, but it is important that you deal with restrictions first. All right. So in example 3, Eric has been assigned the task of determining how many odd 4-digit numbers there are. He has been told that a number such as 5,267 is a 4-digit number, whereas 267 is classified as a 3-digit number. Now, that'll be our rule all the time. This is sort of an introduction where it says he has been told, but it's important for us to understand that this is really a 3-digit number. Because what it's telling us is that the first digit cannot be 0. So when we talk about making a 4-digit number, they're not going to come straight out and say that here's a restriction. It's a restriction that we need to understand. The first digit cannot be 0. All right, so step by step in this example, we're going to learn how to do this question. It says, the first step of his work is shown. Explain the reasoning for the number 5. So in his final spot, which would be for the 4th digit, he says, again, this does not mean that 5 is the 4th digit. It means that there are 5 digits that could go here. So our final digit could be a 1, a 3, a 5, a 7, or a 9. Because in order to be an odd 4-digit number, the final digit has to be an odd number. So there are 5 possible numbers that could go there. Now notice it didn't come out in the question and say there's a restriction on the last digit, it must be odd. It was up to us to understand that that was the restriction. The second step of his work is shown. Explain the reasoning for the number 9. So the first digit, again, it doesn't really come out and tell us, but there is a restriction on the first digit. It could be a 1, a 2, a 3, 4, 5, 6, 7, 8, 9. So those are the 9 possibilities. There are 9 digits that could go in the first spot. The key thing here is it can't be 0. So that's why there aren't 10 possibilities. There are only 9 possibilities. So they've done the tough part for us. It says complete his work to determine how many odd 4-digit numbers there are. So the reason I say that they've done the hard part for us is that they have done the part with the restrictions. So there are 5 digits that could go last. There are 9 digits that could go first. And it doesn't matter what digits go second and third. So all of them are available. So there are 10 digits that could go in the second spot, and there are 10 digits that could go in the third spot. So there are 4,500 possible odd 4-digit numbers that could be made. And then in B, Eric has now been assigned the task of determining how many odd 4-digit numbers there are which have no repeating digits. So now we're looking at sort of a little bit of a trickier question just because there are more restrictions on it. So it says, explain why the first step in A is still valid, but the second step is not. So let's take a look at what we have. So 5 is still valid because we want an odd digit here. So the possible digits that could go in the last spot are 1, 2, 3, 4. Whoops. Let's back that up. Those are not odd numbers. Let me fix up. Sorry for that. 1, 3, 5, 7, and 9. Those are the 5 digits that could go in that last spot. Now it says that 9 is not going to work here. There are not 9 possibilities. There are actually 8 possibilities. And I'll tell you why. Let's put all the digits, single digits down. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, not all 10 of these can go in this spot, and I'll tell you why. We know that 0 cannot go first. And now let's go back to this last digit spot. We said 5 are possible. Let's pretend for a minute that we choose 7 as our final digit. That means now that we cannot repeat digits, it means 7 cannot be used in this first spot either. So what you have are 8 possible digits that could go first. Now, when we go to fill in these next 2, it's not as easy as this 10 and this 10. Because again, we cannot have digits repeating. So just remember that at this point, we've used 1 digit. It happens to be an odd one, but we've used 1 digit for the final digit. We used another digit for the first digit. So there's 2 numbers that have been used. But when we get back to this spot, those 2 numbers that have been used can't be used again, but 0 can be used again. So there are actually 8 digits available for this spot because 2 digits have been used and there's no other restriction. And then when we go to our third spot, there are 7 digits available because we used 1 digit we've used 1 digit for our final spot. We used a second digit here and a third digit here, which leaves 7 digits left to go in here. So a little trickier when you're not allowed to repeat numbers. So if we were to do that multiplying, 8 times 8 times 7 times 5, we would get 2,240 4-digit numbers that are odd and have no repeating digits. So a little trickier. And again, I want just to have that look into the future of something else we'll have to do is we'll eventually do questions just like this where it says, how many odd 4-digit numbers do have repeating digits? If we get asked that question, we'll have to still do all of this same work. We'll figure out how many numbers are there in total. So every single possible odd 4-digit number has been counted up here. Here we figured out how many have no repeating digits. So if we want to know how many do have repeating digits, we would take the 4,500, we would subtract the 2,240, and all the ones that are left would have digits that are repeating. Okay, and number 4. Car number plates in an African country consist of a letter other than I or O, followed by 3 digits, the first of which cannot be 0, followed by any 2 letters which are not repeated. How many different car number plates can be produced? All right, so let's set up our blanks for just so that we can get some thought going on. We have to think about each individual spot. So it says that we start off with a letter that is not I or O. So there is a restriction here. So it's a letter, not I or O. So what we would have in this first spot, now since the alphabet has 26 letters in it, what we would have available, or what is okay to put in this spot, would be 24 different letters that are possible. Now that letter is followed by 3 digits. So let's work on our 3 digits. The first cannot be 0. So we could use any number except 0. So that means there are 9 numbers that could go here. So again, we're not saying 9 is the number we're choosing, but there are 9 digits that could go there. Now it doesn't say there's any restrictions on this spot or this spot. So any of our 10 digits could go here, and any of our 10 digits could go there. And back to the reading. This is followed by any 2 letters which are not repeated. This can be a little bit tricky because since we're back to letters, it almost feels as if it might be connected to the letters that we had here. But this is completely separate. They're not connecting these letters to these ones at all. If we read it again, followed by any 2 letters, so there's 26 possible letters, any 2 letters which are not repeated. So within these 2 letters, there are no letters being repeated, not connected at all to what's going on up here. So careful reading is really important. So there would be 26 possible letters that could go here. Now let's pretend that we chose X to be that number. X cannot be used again, so there'd be 25 letters that are possible here. So we multiply all of that out. We get 14,040,000 different license plates. Now, you guys might be a little bit young to know this, but your parents will know that a few years back, Alberta, with the license plate plan or rules that they had going on, actually ran out. They didn't have enough license plates, and they had to add in an extra digit. We used to just have 3 letters and 3 numbers, and it went to, what is it now? 3 letters and 4 numbers, I believe. So you'll see a few different license plates around, and that's why we had to add on, because there weren't enough license plates with the plan that we did have. So kind of interesting. Your parents can probably tell you more about that too. All right, that's it for today, you guys. So getting a little trickier dealing with the restrictions. And I think sometimes the hard part is they don't come out and tell you that there's a restriction. You need to use sometimes your common sense and realize, hey, there's a restriction on this last digit. It has to be odd. Or there's a restriction on the first digit. It can't be 0. So some of the restrictions we're expected to know already. All right, so time to give this practice assignment a try. Make sure that you look at my answer key. It might help you with your questions. Or you can also get help, as it says on Google Classroom. There's always a few different ways to get help. You can just email me if you want, or you can use the question answer forms. And if you're doing this on a Monday, Wednesday, or a Friday, you can get the help time one-on-one in the afternoon as well. Just book it through my calendar. All right, guys, have a great day, and we'll have more tomorrow.